Two-stroke engines have been used in a wide variety of applications, from motorcycles to lawnmowers, due to their simple design and high power-to-weight ratio. Unlike a four-stroke engine, which requires 4 piston strokes to complete one power cycle, the two-stroke engine achieves the same process in just 2 piston strokes, delivering more power in less time. In this video, you'll learn how a two-stroke engine works. Before we get into the process, let's take a look at the key components that make up a two-stroke engine. At the heart of it all is the piston, moving up and down inside the cylinder. Unlike in a four-stroke engine, where intake and exhaust valves are used to manage the flow of gases, here we have the exhaust port, the inlet port, and the transfer port. The piston itself covers and uncovers these ports at specific points during its movement, controlling the intake and exhaust process. The crankcase, located below the cylinder, plays a crucial role too. It houses the crankshaft and acts as a pump for the fuel-air mixture. The two-stroke engine operates with just 2 distinct phases, the power stroke and the compression stroke. Let's begin with the power stroke. The cycle starts when the piston is at its highest point. At this point, the air-fuel mixture inside the combustion chamber is fully compressed. The spark plug ignites the mixture, creating a rapid combustion reaction. This explosion generates high-pressure gases, forcing the piston downward. As the piston moves down, it first uncovers the exhaust port. This allows the burnt gases from the combustion process to escape from the cylinder through the exhaust port. The timely removal of these gases is critical, as it makes room for the incoming fresh fuel-air mixture. The piston keeps on moving down, squeezing the fuel-air mixture in the crankcase. As the piston descends further, it reaches a point where it uncovers the transfer port. At this moment, the fresh air fuel mixture is released from the crankcase and fills the cylinder above it, pushing out the remaining burnt gases through the exhaust port. Moving on to the compression stroke. As the piston moves up, it clears the intake port, drawing in the fresh air fuel mixture from the carburetor that fills the crankcase. As the piston ascends further up, it closes off exhaust, transfer, and inlet ports, sealing the combustion chamber. With all the ports closed, the fresh air-fuel mixture that entered the cylinder during the first stroke is now trapped. As the piston rises, the mixture becomes compressed, increasing the pressure and temperature inside the combustion chamber. This sets the stage for ignition by the spark plug, starting the cycle all over again. One of the key distinguishing features of a two-stroke engine is its use of the crankcase as a pump for the fresh fuel-air mixture. While in a four-stroke engine, a separate stroke is dedicated to the intake of the air-fuel mixture, a two-stroke engine accomplishes this during the downward movement of the piston. Two-stroke engines have a unique approach to lubrication. Instead of relying on a separate oil circulation system, most two-stroke engines mix oil with the fuel, a process known as petrol lubrication. This oil helps lubricate the moving parts. However, the lubricating oil can sometimes find its way into the cylinder, where it burns, creating the blue smoke commonly seen in two-stroke engines. Two-stroke engines are simpler, lighter, and offer more power strokes per cycle compared to four-stroke engines. However, they tend to be less fuel efficient, and their exhaust gases contain unburned fuel, making them more polluting and expensive to run in the long term. Despite their drawbacks, two-stroke engines continue to power many machines today due to their simplicity and power output. Understanding their operation gives us insight into how engines shape the technology around us. If you enjoyed this video and want to see more educational content, be sure to subscribe to our channel. Thank you for watching.